So, welcome children, today grade 9 maths probability the chapter. Now, the second part of the chapter 15. Now, come to the point, let E be an event, E be an event of an experiment, then the probability of the event E plus probability of the event not E, so is equal to 1. That is sum of the two opposite events. I already explained you in the earlier class. So, probability of an event plus probability of not E. Not E means that is opposite to that event. Okay. So, if you add, you get 1. So, P of E plus P of E bar. If E and E bar are opposite events, E and E bar are opposite events. So, if you add the probability, that is the value of the probability, then you get 1. So, you have to take this point also. You can see that example here for this formula. If the probability of winning a game, for example, you can consider any game, the winning, otherwise losing. So, that is the result of the every game. So, here if the probability of winning a game is 0.4, so they have given the probability of winning the game is 0.4. So, you know the value of the probability of any event lie between 0 and 1. So, that point we have already discussed. So, it is given that the probability of winning a game is 0.4. So, 0.4 is between 0 and 1. Okay. Now, the question is, what is the probability of losing it? So, losing it means what? So, losing the game means what is the probability? If winning probability given means, so how to find the probability of the losing the game? So, now we have to apply this formula. You see, we have to write the formula. We know that probability of any event E, and if you add with the probability of not E or E bar, anything you can write. So, not E means nothing but E bar, opposite to the happened event E. So, that is E bar or not E, in any way you can say. So, probability of the event E plus probability of not E. So, sum of the two opposite events, sum of the probability of two opposite events is equal to 1. Okay. So, in an experiment, okay. So, here the experiment is the game. So, in that game winning probability and loss probability it is given. So, we can write this as that event E here we consider as winning a game. Okay. Therefore, losing a game means not E, that is which is opposite to winning game. Losing a game is opposite to winning a game. So, you have to take that is not E. So, that is losing a game. If E you have take as winning a game, then not E, that means E bar you can take as losing a game. So, if you add both probability, that you know which is equal to 1 according to this formula. So, probability of winning a game plus probability of losing a game is equal to 1, and therefore, you have to keep probability of losing a game, because in that question part they are asking what is the probability of losing, it means that game. Okay. So, you have to keep that at left side and you transpose this probability of winning a game to right side. What happens? Implies the next step, probability of losing a game is equal to 1. So, here on the right side already 1 is there. So, put 1 and then minus, because here it is plus. So, here minus P of winning a game, minus P of winning a game. So, you know that probability of winning a game is given in the question, that is 0.4. So, look here 0.4, you have to write that value which is the probability of winning a game. P of means what? Probability of winning a game, that is 0.4. So 1 minus 0.4, if you subtract, you get 0.6. So 0.6 also lie between 0 and 1. Okay. So 0.6 is the value of the probability. Probability is nothing but a measure. Okay. So measure of the value of the event. Okay. The probability means. So 0.6 is the probability of losing a game. If we add these two, you see 0.4, 0.6. If we add, what do you get? 1. So we have to apply this formula to find the answer for this type of questions. And now we move to the remaining problems in that exercise 15.1. In the previous class we have finished up to 4 sums, I think. So now let me start from 5th sum. Okay. So now coming to question number 5. An organization selected 2400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. So they have related their income and also the number of vehicles. Okay. The information gathered is listed in the table. So this table is given in your book, and you see MI. So this is monthly income. Okay, you can see in your book. So vehicles per family. So one family own how many vehicles? So like that the list is given. 0 means no vehicle. 1 means only one vehicle. 2 means just 2 vehicles. Above 2 means they are having more than 2 vehicles. So like that it is number. So income here less than 7,000. So their income is less than 7,000, and 10 family have no vehicles, and 160 family have 1 vehicle, 25 family have 2 vehicles, and no family have more than 2 vehicles. So they are come under the income level less than 7,000. So like that up to 16,000 or more. So up to that they have given this data, and the question 5 options are there. So suppose a family is chosen. So you have to select a family under this option. Find the probability that the family chosen is earning rupees 10,000 to 13,000 per month. So first of all you have to write the solution part, total number of families. So this you don't write this. Okay, no need to write. So you have to observe the data from this table, and solution from this you have to start. Question number, and from this you start. Okay. So total number of families is equal to 2400. It is given in your book, and the first option, so you have to read it. 10,000, the income level is 10,000 to 13,000. You see where it is, this 10,000 to 13,000 is the income level, and this is per month. Okay. And then and owning exactly 2 vehicles. Exactly 2 vehicles. So exactly 2 vehicles means, you see, so under this 2, this is the number of vehicles 2. So straight to this, so this row and this column you have to see. So you see this is 29, right? You have to take 29 family whose income level is 10,000 to 13,000 and owning 2 vehicles. So that is 29 family. So you have to find the probability for that. Okay. So first option. So number of families earning rupees 10,000 to 13,000, and owning means having, they own that number of vehicles. The owning how many? 2 vehicles. It is given in the question. Is equal to how many? 29 families. You see, just I encircled it. So this number of families comes under the income level 10,000 to 13,000, and they own 2 vehicles, that is 29. So you have to find the probability for that. So if you consider So this as event E. Okay, let the event A colon you have to put. Okay, let the event A colon. So this is the event. Number of families earning 10,000 to 13,000 and owning 2 vehicles is equal to 29. Okay, we have to take that event name as A. Therefore, P of A represents the event of the first option. So 29 by total number of trials, that means here total number of outcomes like that you have to take. So in the numerator you have to write the number of families earning this level and owning 2 vehicles is 29 divided by total number of family. So that is 2400. So that's all the answer. You cannot simplify it. Okay, so that's all answer. And then option 2, let B the event. You consider that B as the event, that is the family earning rupees 16,000, number of families earning rupees 16,000 or more and owning exactly 1 vehicle. One vehicle equal to, so how much? Number of families earning 16,000 or more per month and owning exactly 1 vehicle. So like that you have to take. So that we have to see from the table. So that is 16,000. You see 16,000 or more and owning exactly 1 vehicle means, you see under this column you have to see. So 1 vehicle and earning 16,000 or more. So that is 579. So you have to write here 579. So therefore, P of B means that event. Okay, P of B is equal to, in the numerator you have to write 579 number of families for this event and total number of possible outcomes, that is 2400. So this also you cannot simplify. So if not simplified means that is also correct. Okay, if needed you can simplify. So 517 by 2400 is the final answer. That's all. And option 3, let this event be C. Okay, you have to name it as let C. So colon means you have to write the matter what is given in the option 3. So the family earning less than 7,000 per month. So earning number of families earning less than 7,000. So rupees you have to write per month. Okay, less than 7,000 and does not own any vehicle. Own any vehicle. So that is equal to. So what is the number? Less than 7,000 per month means here, and owning no vehicle means that is 0 vehicle. So you have to match this row and column. So that is 10. Am I right? So like that you have to take from the table. So now probability of the event C, that is 10 by the total 2400, and here you can cancel 1 0, then you have 1 by 240. So this is the final answer. And coming to the next one, option 4. So let the event be D. Okay, and is given that number of families earning 13,000 to 16,000 per month. Earning rupees 13,000 to 16,000 per month, and owning more than 2 vehicles, owning more than 2 vehicles, that is equal to, we have to see from the table, 13 to 16,000. So, it is here 13,000 to 16,000, and more than 2 vehicle means it is here above 2, under that we have to see. So, this row and this column. So, this is 25. Okay. So, you have to write 25 here, and therefore, probability of D, D means this event, the above event is named as D. So, probability of D is equal to 25 by 2400, and if we cancel 25 by 2400, you will get 1 by 96, because if you can use 25 table. So, 25 ones are 25, and you cancel 2400 by 25, you get 96. So, 1 by 96 is the final answer for this option. So, now option 5, you have to consider this as event E. So, it is given number of families owning not more than 1 vehicle. Not more than 1 means you have to consider 0 and 1. Okay, that is not more than 1. So, number of families having 0 vehicle and number of families having 1 vehicle, you have to sum up. So, from the table, the first 2 columns you have to add. So, you get, if you add this, you will get 2062 by 2400. So, this is what probability of E. Okay. The probability of the event E is, if you add all this, you get 2062 divided by 2400, and if you cancel, you will get 1031 by 1200. So, this is the final answer. So, now coming to question number 8, you have to see page number 245. So, it was given the distance in kilometer of 40 engineers from their residence to their place of work, where found as follows, like that it is given. Okay. So, the number of engineers, they are working in a place. So, the distance from their residence, okay, in kilometer it was given there. So, from starting from 5, 3, 10 like that, the 40 engineers residence distance is given from the workplace. Okay. So, it is easily visible. So, you can collect the data for this question. You see, the first option, total number of engineers you have to take as 40. Option 1, let A, this 40 is given in that question in page number 245. Okay. So, you have to take the first option as event A. It is given the number of engineers whose residence is less than 7 km from their workplace. Okay, slightly I have changed that sentence. So, what is the empirical probability that an engineer lives less than 7 km from her? So, you change as that, from their place of work, that it was given. So, I have taken like this, number of engineers whose residence is less than 7 km from their workplace. So, how many engineers are living this distance less than 7 km from their workplace, means 9 of them are, okay, living. So, you have to count the kilometers given there in numbers, 40 numbers are given in under that question. So, you have to take which are less than 7. Less than 7 means from 1 to 6 you have to collect. So, I have collected the numbers and I have counted how many numbers are less than 7. It was 9. Okay, 9 numbers are there. So, that means 9 engineers are living from their workplace less than 7 km. Clear? So, now we have to find the probability of this event, that is 9 by total 40 engineers. So, 9 by 40 is the answer. On option 2, it was given more than or equal to 7. So, let B, we have to take as B. So, number of engineers living more than or equal to 7 kilometer equal to 7 kilometer from their workplace is equal to how many means 31. How I am telling? Because by applying that the point, that formula P of E plus P of E bar equal to 1, here the number of engineers living from their workplace less than 7 kilometer is 9. Okay, out of 40, if we subtract 9, we get 31. So, therefore, more than or equal to 7 kilometer. More than or equal to 7 kilometer means from 7 and more than 7 we have to consider. Okay. So, that means these two are opposite, yes or no? So, the first option less than 7 and the second option 7 and more than 7, because the word given more than or equal to. More than or equal to mean what? 7 and more than 7, that means these two are opposite events. So, we have to subtract 9 from the total number of engineers 40, because it was 9. So, if you subtract that, you get 31. So, if you add 31 and 9, then you get 40, because they two are opposite events, that is all. So, easily you can write the probability, that is P of B is equal to 31 by 40. So, this is very easy to answer, clear. And now, option 3, you see option 3, number of engineers lives within half kilometer, 1 by 2, within half kilometer from their place of work. So, nobody, because in that given data nobody having their residence half kilometer from their workplace. So, it was not given there. So, 0 we have to take, let C an event, that is number of engineers living within half kilometer equal to 0. So, nobody is living within the half kilometer distance, okay, from their workplace. So, the probability 0 by 40, that is nothing but 0 only. Okay. So, this is the way you have to answer. And question number 9, you see activity is given, 10 also activity. So, the question number 9, note the frequency of 2-wheelers, 3-wheelers and 4-wheelers going past during a time interval in front of your school gate. It was given. So, you consider that as your home gate. So, you have to find the probability that any one vehicle out of the total vehicles you have observed is a 2-wheeler. For example, I will tell you how to do this activity, you take it as homework. Okay. So, ninth sum, 2-wheeler, 3-wheeler, 4-wheeler. Okay. So, you consider a time interval, for example, morning after finishing a breakfast 10 to 11, you consider the time. In that 1 hour interval, how many 2-wheelers you go and sit in your balcony or in the gate side of your home, you see how many 2-wheelers or 3-wheeler or 4-wheeler passing through your street, okay, and you have to count. For example, 2-wheeler some 5, 3-wheeler some 4 and 4-wheeler some 10. Okay, this is number of vehicles and this is category 2-wheeler, 3-wheeler, 4-wheeler, and the probability you have to find for 2-wheeler. So, 2-wheeler total vehicle is, you have to count this total is equal to 10, 14, 19. So, 19, and you have to find the probability for 2-wheeler. So, probability of 2-wheeler which passed through your street in that interval of time is 5 divided by the total vehicles is 19. So, you consider this as vehicles and this is as category. Okay. So, in this way you have to do your activity. This is the format I have given you. So, this is not the answer, okay. This is the format. So, you can do by yourself. So, it may vary for you. So, you have to consider this one and you have to do like this, clear. And next one activity, the question number 10, very interesting activity that also. So, it was given that in the classroom, just as a teacher I had to ask the students to write a 3-digit number. Choose any student from the room at random. What is the probability that the number written by her or him, say boy or girl, okay, is divisible by 3. So, in the class suppose 10 students are there, means 10th question, total students equal to 10, for example, okay, you take it like that. Suppose I am asking the 10 students to write any 3-digit number, okay, one writing like this 108, another one writing as 212, and then 105, and then 303, 404, 1, 2, 3, 4, 5, and then 6th student writing 506, and then next 702, 611, and then 999, and then 990. For example, the 10 students have written like this, the 3-digit number, and the question is, which number is divisible by 3? Suppose I am asking a student and checking whether the number written by her or him is divisible by 3. You know, a number divisible by 3 means the sum of the digits, if you add all the digits, that total should be divisible by 3, then that number is divisible by 3. So, here how many numbers are divisible by 3? You have to find the probability that number is divisible by 3, okay. For example, number of numbers, 3-digit numbers, divisible by 3 is equal to, so you have to check, you know, if you add 1 plus 0 plus 8, that is 9, which is divisible by 3. So, I am just encircling those numbers which are divisible by 3. So, this 2 plus 1 3, 3 plus 2 5, it will not divisible by 3, it is 6, so divisible by 3, and this also divisible by 3, and 8 9, this also divisible by 3, 5 0 6, if you add you get 11, so not divisible by 3, and 7 or 2 will be divisible by 3, this will not be divisible by 3, this will be divisible by 3, and this will not be divisible by 3, okay. So, like that you have to check. And now, how many numbers are divisible by 3? 1 2 3 4 5 6, so 6 numbers, okay. Suppose the event I am taking it as A, then P of A equal to 6 by the total numbers is 10. So, if I simplify, 2 3s are 2 5. So, now 3 by 5 is the probability. This is a sample given for you. So, you have to do like this anyway. Okay, any number you can write, and the probability value may different. So, this is a sample for this is an activity. Okay. And now coming to question number 11, 12 and 13, these are very easy one. So, you have to take as a homework all this, find the probability of the each question. And 12th and 13th question, you see in question number 5, exercise 14.2. So, that means you have to go to 14.2. I will show you that page number. So, 14.2 and question number 5. So, that question is 245 page. Question number 12. Question number 12, the page number 245. Fifth question, 245. Fifth question, you have to take as the data for this question. And 13th one, you see question number 1 in exercise 14.2. So, that also same page number 245. Question number 1. So, it is given. Okay. And you have to find the probability for the given event. So, it is very easy for you. Worksheet also sent to you. You finish that. Thank you.